At 8:40 in the morning Mountain Daylight Time today, the National Weather Service office in Cheyenne, Wyoming, issued a blizzard warning for the I-80 corridor from Laramie to Rawlins. The product language was operational, almost clinical. Snow accumulations of 12 to 18 inches in the higher elevations, winds gusting to 50 miles per hour, visibility less than 1/4 mile for 3 hours or more. The warning read like a January product, not a May product. 3 hours later, and 2 time zones to the east, the National Weather Service office in Boston, Massachusetts, published their area forecast discussion for the afternoon. Buried inside the discussion, in the section where forecasters talk about model confidence and mesoscale uncertainty, was a sentence that does not show up very often. The sentence read, "Forecast 850 millibar temperatures on Monday afternoon will be 2 to 3 standard deviations above the CFSR climatology for this date, close to the maximum relative to climatology for the period of record." A blizzard warning and an all-time May heat record forecast issued by the same agency on the same calendar day. That is the contradiction we have to sit with. As of 11 a.m. Eastern Time today, 404 active alerts are in force across the United States. Not watches, not statements. Warnings and advisories. The breakdown tells you everything about what the atmosphere is doing right now. Wyoming alone is sitting on 31 active alerts, most of them winter weather products. Colorado has 27. Montana has 24, but scroll down the national alert map and you find Kansas at 22 alerts, Nebraska at 19, Missouri at 29, Texas at 34. Those are not winter alerts. Those are tornado watches, severe thunderstorm warnings, flash flood warnings, and extreme fire weather warnings. The National Weather Service has run out of seasons to issue products against. They are issuing a blizzard in the same hour they are issuing a heat advisory for Boston, a moderate risk of tornadoes for the Central Plains, an extreme fire weather warning for the Texas Panhandle, and a flash flood watch for the Missouri Ozarks. Every season is represented. Every categorical operational extreme is running simultaneously, and the question that has to be asked is not whether this is unusual, the question is what is driving it. The answer is one Rossby wave, one amplified, high-amplitude Rossby wave that has wrapped itself around the mid-latitudes of North America and locked into a configuration that the climate models said should not be happening this often and this early in the year. The honest framing on social media this morning is calling it a convergence event, or a once-in-a-generation pattern, or in the less serious corners of the internet, something that HAARP did, or something that chemtrails caused. The framing in the peer-reviewed literature has a different name. The literature calls it quasi-resonant amplification of planetary Rossby waves. And we need to walk through what that phrase actually means, why it is producing a blizzard and a heat wave on the same day, what loaded the gun, and why the open question at the end of this video is the one that nobody has a good answer to yet. Start with the day itself. Go back to Wyoming. The blizzard warning that went out at 8:40 a.m. MDT was not a borderline product. The National Weather Service does not issue blizzard warnings casually. The criteria are specific: sustained winds or frequent gusts of 35 miles per hour or greater, considerable falling and blowing snow, visibility less than 1/4 mile, and these conditions must persist for at least 3 consecutive hours. The Cheyenne office put the I-80 corridor under that warning, with language that included the phrase, dangerous to impossible travel. That phrase does not show up often for a May storm. The setup is classical upslope flow. A deep upper-level trough has dug into the Intermountain West, wrapping cold air down from Canada. As the flow rounds the base of the trough and slams into the Laramie Range, the air is forced to rise. The east-facing slopes of the Medicine Bow Mountains, the Snowy Range, and the North Laramie Range are the focal points. The I-80 summit between Laramie and Cheyenne sits at over 8,600 feet. The temperature at that elevation this morning was 28 degrees Fahrenheit. The dew point was 26. That is a near-saturated column. As the upslope flow continues through the day, the lift will produce snow rates of 1 to 2 inches per hour. The wind will create ground blizzard conditions even where the snowfall totals are lower. The transportation corridors are going to close. That is not speculation. That is the language of the warning itself. Now flip to Boston. The area forecast discussion from the Boston National Weather Service office issued at 11:40 a.m. Eastern Time, contained a paragraph that deserves to be read slowly. The forecaster wrote, "The 12 ZGFS and NAM both show 850 millibar temperatures in the 18 to 20 degrees Celsius range on Monday afternoon, which is 2 to 3 standard deviations above the CFSR climatology for this date." Then came the line that matters, close to the maximum relative to climatology for the period of record. The period of record for the CFSR reanalysis goes back to 1979, 46 years of daily 850 millibar temperature observations. And the forecast for Monday is close to the maximum of that entire 46-year record. Not above average. Not well above average. Close to the maximum. Pause on that sentence, because it is the sentence that this entire video turns on. When an operational forecaster at a National Weather Service office writes that a temperature at the 850 millibar level is close to the maximum of the climatological record, they are not being hyperbolic. They are describing the edge of the envelope. Translate what that means at the surface. The 850 millibar level is approximately 5,000 feet above sea level. The temperature forecast at that level is 18 to 20 degrees Celsius. Convert that. 18 degrees Celsius is 64.4 degrees Fahrenheit. 20 degrees Celsius is 68 degrees Fahrenheit. So at 5,000 feet, the atmosphere is forecast to be 64 to 68 degrees. Now translate that to the surface. As an air parcel descends from 5,000 feet to sea level, it warms by adiabatic compression at the dry adiabatic lapse rate, approximately 5.5 degrees Fahrenheit per 1,000 feet of descent. A parcel that starts at 64 degrees at 5,000 feet and descends to sea level will warm by roughly 27 to 28 degrees. That puts the surface temperature at 91 to 92 degrees Fahrenheit before you add any daytime heating. If the parcel starts at 68 degrees at 5,000 feet, you get 95 to 96 degrees at the surface. And, if the mixing is efficient, which it often is in these high-amplitude ridge regimes, you can mix even warmer air down from just above the boundary layer. That is how you get mid-90s to near 100-degree temperatures in Boston in May. The same physics that produces the blizzard in Wyoming, the lift and the condensation and the release of latent heat, is the same physics that produces the heat wave in Boston, the subsidence and the compression and the adiabatic warming. The trough and the ridge are mechanically coupled. You cannot have one without the other. The same wave is doing both things at the same time. The heat in Boston matters not just because it is close to the maximum of the climatological record, but because it is the first heat of the season. The epidemiological literature on heat mortality has a consistent finding. Early season heat waves kill more people than late season heat waves of the same magnitude. The reason is acclimatization. In May, people have not yet built up physiological tolerance to high temperatures. Air conditioners have not been serviced or turned on. The urban heat island effect, which is always present, becomes dangerous when the population is not ready for it. The National Weather Service has already designated Monday as a major heat risk day for eastern Massachusetts. Major is the second highest tier in the heat risk product, which is a collaboration between the NWS and the CDC. Major means that the heat will affect anyone without effective cooling and adequate hydration. And because this is May, adequate hydration is not yet a reflexive behavior for most people. The risk is real. But the story is not Wyoming and Boston. The story is the simultaneity. The same upper-level trough that is digging into the Rockies and producing the upslope blizzard is also the same trough that is ejecting energy into the Central Plains. That ejection of energy is what the Storm Prediction Center has been watching for 3 days. At 8 a.m. this morning, the SPC issued a Day 1 convective outlook that upgraded a large portion of Kansas, Nebraska, and Missouri to a moderate risk. The SPC uses 5 categorical tiers for severe weather: marginal, slight, enhanced, moderate, and high. Moderate risk is the 4th tier. It occurs on approximately 6% of days in an average year. The language in the moderate risk outlook is not casual. The SPC wrote, "Very large to giant hail, 2 to 4 inches in diameter, will be possible with any supercell that can mature in the open warm sector." The same text continued, "Multiple strong to intense tornadoes, EF2 or greater, are expected as the low-level jet intensifies after 21Z, that is 5 p.m. Eastern Time. The same wave that is putting snow on Interstate 80 is putting the atmosphere in the plains into a configuration where the wind shear is 50 to 60 knots in the lowest kilometre. The convective available potential energy is 3,000 to 4,000 joules per kilogram, and the lifted condensation levels are low enough that any thunderstorm that forms will have a real shot at rotating. The wave did not choose to produce a blizzard in one place and a tornado outbreak in another. The wave produces the large-scale ascent and descent. The local geography and the local thermodynamics decide the hazard. Now add the fire weather. The Storm Prediction Center does not only issue severe thunderstorm and tornado outlooks, they also issue fire weather outlooks. Today, the SPC has placed the southern high plains, including the Texas Panhandle, western Oklahoma, and far southwestern Kansas, in an extreme fire weather tier. Extreme is the highest category in the fire weather outlook system. It means that conditions are such that any ignition will likely produce rapid fire spread, high resistance to control, and extreme fire behavior. The numbers behind that designation are sobering. Sustained winds of 35 to 45 miles per hour, relative humidity in the single digits, and temperatures in the upper 90s to low 100s. The fuel moisture, which is measured by the energy release component and the 100-hour fuel moisture, is at the 90th percentile of historical values for this date. That is not a typo. The 90th percentile of dryness. The fuels are as dry as they have ever been in the observational record for the third week of May. The Texas Panhandle has already had one catastrophic fire this year. The Smokehouse Creek fire in late February burned over 1 million acres. That fire happened when temperatures were 20 degrees cooler and the winds were 10 miles per hour lighter. Today is worse. The script that fire behavior analysts use is the same script every time. High probability of ignition under high consequence spread conditions. If a spark happens, and it will, the fire will move at a rate that outruns most initial attack resources. The flash flooding in Missouri is the fifth face of the same wave. The same trough that is ejecting energy into the plains is also pulling deep moisture northward from the Gulf of Mexico. Precipitable water values across Missouri and Arkansas are 1.8 to 2.2 inches, which is the 95th percentile for May 18. The training thunderstorms, the ones that move repeatedly over the same location, are already starting to show up on radar. The Weather Prediction Center has issued a moderate risk of excessive rainfall for the Missouri Ozarks. Moderate in that product means that widespread flash flooding is likely, with the possibility of significant or even catastrophic flooding in some locations. The ground in Missouri is already saturated from a wet April. The soils cannot take any more water. The rainfall rates of 2 to 3 inches per hour that are forecast will produce runoff almost immediately. The same wave, the same large-scale ascent, the same coupling between the trough and the ridge produces the record heat and the blizzard and the tornadoes and the fire weather and the flash flooding. The National Weather Service has issued products for every season: winter, spring, summer, fall, all on the same calendar day. This brings us to the physics. What is a Rossby wave? The name comes from Carl Gustaf Rossby, a Swedish-born meteorologist who in the 1930s and 1940s developed the mathematical framework for understanding large-scale atmospheric waves. A Rossby wave is a planetary scale undulation in the mid-latitude westerly wind belt. The westerlies do not flow in a straight line around the northern hemisphere. They meander. The meanders are Rossby waves. The waves are driven by two things: the Coriolis effect, which is the deflection of moving air due to the Earth's rotation, and the equator-to-pole temperature gradient, which is the fundamental thermodynamic driver of the global circulation. When the temperature gradient is strong, the waves are small in amplitude and fast in propagation speed. When the temperature gradient weakens, which is happening as the Arctic warms faster than the mid-latitudes, the waves slow down and grow in amplitude. That is the basic idea. The phenomenon that matters for today is not ordinary Rossby wave meandering. It is something called quasi-resonant amplification. In 2013, a team of researchers led by Vladimir Petukov at the Potsdam Institute for Climate Impact Research published a paper in the Proceedings of the National Academy of Sciences. The paper showed that when Rossby waves take on certain wave numbers, specifically wave numbers 5, 6, and 7, they can get stuck. The waves stop propagating. They resonate, and when they resonate, they amplify. The ridges become higher. The troughs become deeper. The weather patterns that are associated with those ridges and troughs become more extreme and longer lasting. The Petukov paper was theoretical. It was based on a simplified model of the atmosphere. But the observational work that followed has confirmed that quasi-resonant amplification is a real phenomenon and that it is happening more often than the models predicted. The most important observational work comes from a series of papers by Kai Kornhuber and colleagues. In 2020, Kornhuber published a paper in Nature Climate Change that examined concurrent weather extremes across the Northern Hemisphere. The paper found that when quasi-resonant amplification occurs, the risk of simultaneous heat waves, floods, droughts, and fires increases by a factor of 20 times. That is not a small number. That is the difference between a rare event and a regular occurrence. The paper also found that wave numbers 5 and 7 are the ones that produce the most severe concurrent extremes. Wave number 5 means that there are 5 ridges and 5 troughs around the Northern Hemisphere. Wave number 7 means 7 ridges and 7 troughs. Today, the Northern Hemisphere wave number is 6 ridges, 6 troughs. One of the ridges is over the eastern United States, producing the Boston heat wave. One of the troughs is over the western United States, producing the Wyoming blizzard. The other ridges and troughs are producing extremes in Europe, Asia, and the Arctic. The wave is circumglobal. The United States is just one part of the pattern. The Kornhuber work from 2020 was important. The Kornhuber work from 2023, published in Nature Communications, was more important for the question we have to ask at the end of this video. In the 2023 paper, Kornhuber and his co-authors compared the observed frequency of quasi-resonant amplification events to the frequency projected by the CMIP6 climate models. The CMIP6 models are the state-of-the-art. They are the models that the Intergovernmental Panel on Climate Change uses for its assessment reports. The Kornhuber paper found that the models systematically underestimate the frequency and intensity of quasi-resonant amplification. The models say that events like today should happen once every 10 to 15 years. The observations suggest that they are happening once every 3 to 5 years. That gap between the models and the observations is not a small discrepancy. It is a signal that something in the models is missing. The paper suggests that the missing piece might be the interaction between the mid-latitude waves and the Arctic amplification, the faster warming of the Arctic relative to the rest of the planet. The models do not capture that interaction well. The result is that the models are too conservative. They are telling us that the atmosphere is less extreme than it actually is. Before we go further into the open question, we have to talk about what loaded the gun. The Rossby wave did not amplify in a vacuum. The preconditions set the stage. The first precondition is the drought. The spring of 2026, January through April, has been the second driest such period in the 131-year instrumental record for the contiguous United States. Only the spring of 1934, during the Dust Bowl, was drier. The Palmer Drought Severity Index, which integrates temperature, precipitation and soil moisture, is currently at -4.2 for the southern plains and -3.8 for the Midwest. The Dust Bowl values were around -5, so this is close. The drought matters for the heat wave because of soil moisture-atmosphere coupling. The mechanism is straightforward. When the soil is wet, the sun's energy goes into evaporating water. That is evaporative cooling. When the soil is dry, there is no water to evaporate, the sun's energy goes directly into sensible heat, which warms the air. The difference is not small. A 2019 paper by Morales and colleagues in PNAS used observational data and model simulations to show that dry soil increases the likelihood of extreme heat by approximately 30%. That is a direct causal link. The drought that is happening right now, the drought that is approaching Dust Bowl levels, is making the heat wave in Boston worse. It is also making the fire weather in Texas worse. It is also making the flash flooding in Missouri worse because dry soil is not the same as hard soil. When the rain comes, it runs off instead of infiltrating. The second precondition is the aerosol unmasking. In 2020, the International Maritime Organization implemented Regulation EIMO 2020, which reduced the allowable sulfur content in marine fuels from 3.5% to 0.5%. That regulation had the intended effect of reducing air pollution from shipping. It also had an unintended effect. Sulfate aerosols reflect sunlight. When the IMO reduced sulfate emissions over the North Atlantic, they reduced the reflective aerosol loading. More sunlight reached the ocean surface. The sea surface temperatures in the North Atlantic warming hole, the region that had been anomalously cool due to aerosol forcing, began to rise. A 2023 paper by James Hansen and colleagues in Communications, Earth and Environment attributed the rapid warming of the North Atlantic to the IMO 2020 regulation. That warming has consequences for the Rossby wave pattern. The Bermuda High, which is the semi-permanent high-pressure system over the western North Atlantic, is stronger and warmer than it would otherwise be. That strengthens the ridge over the eastern United States. That ridge is the same ridge that is producing the Boston heatwave. The aerosol unmasking is not the only driver, but it is a contributor. The third precondition is the ENSO transition. The El Niño Southern Oscillation is currently in a neutral phase, but the forecast from the Climate Prediction Center issued last week gives an 82% probability of El Niño developing by July. The transition from neutral to El Niño is often associated with changes in the large-scale wave pattern. During El Niño, the subtropical jet stream strengthens and extends further eastward. That can amplify the Rossby wave response. The current wave pattern is consistent with what you would expect during the early stages of an El Niño transition. The model ensemble means are showing a continued increase in wave amplitude as we move through the summer. That is not a forecast of constant extremes. It is a forecast of a pattern that is conducive to extremes. The fourth precondition is the megadrought baseline. A 2022 paper by Williams and colleagues in Nature Climate Change documented the ongoing 22-year megadrought in the southwestern United States. That megadrought is the driest 22-year period in at least 1,200 years. The megadrought is not news. But what the paper emphasized is that the megadrought has lowered the baseline soil moisture across the entire western half of the country. The current drought is building on a base that was already depleted. That is why the Palmer Drought Severity Index values are approaching Dust Bowl levels. The Dust Bowl was a multi-year event. The current megadrought plus the spring drought has produced a soil moisture deficit that is comparable in magnitude. That deficit is the fuel for the heat wave and the fire weather. It is the loaded gun. The Rossby wave is just the trigger. The open question that the literature has not yet answered is whether the days when the wave amplifies are becoming more frequent. The Kornhuber 2023 paper suggests that they are. But the paper also notes that the observational record is still too short to make a definitive statement. The satellite era, which gives us good global coverage of Rossby wave structure, only goes back to 1979. That is 46 years. For a phenomenon that might have a natural decadal variability, 46 years is not enough time to separate the signal from the noise. The honest answer is that there is debate in the research community about whether quasi-resonant amplification is becoming more common, or whether we are just seeing a cluster of events in a period of natural variability. The 2023 paper comes down on the side of a real increase. The 2013 paper was theoretical. The 2020 paper documented the increased risk. The 2023 paper showed the model observation gap. That is 3 papers in 10 years. The weight of the evidence is shifting, but the question is not settled. That is the open question we have to leave on the table. Now we have to address the other stories that are circulating today. There is a geomagnetic storm happening right now, AG1, which is minor, caused by a coronal mass ejection that left the sun 2 days ago. G1 storms are common. They happen about 1,500 times per solar cycle. They produce auroras at high latitudes and have no measurable effect on weather. The Rossby wave that is driving today's extremes has an energy content on the order of 10 to the 25th joules. That is a 1 followed by 25 zeros. The HARP facility in Alaska, which some people on social media have suggested might be influencing the weather, transmits at approximately 3.6 megawatts. That is 3.6 times 10 to the 6th watts. The energy mismatch is 19 orders of magnitude. There is no physical mechanism that would allow a 3.6 megawatt transmitter to control or modify a 10 to the 25th joule atmospheric wave. The same logic applies to chemtrails. The amount of material that would need to be injected into the atmosphere to modify the large-scale circulation is measured in billions of tons. There is no evidence of that happening. The honest framing is the one we have to leave you with. There is no physical mechanism that links geomagnetic storms, HARP, chemtrails, or solar activity to the Rossby wave pattern. The pattern is driven by the temperature gradient, the Coriolis effect, and the amplification mechanisms that Petukov and Kornhuber and others have described. The conspiracy theories are a distraction from the real question, which is why the models are underestimating the frequency of these events. The same wave, the same calendar day, the same physics. Wyoming is sitting on 31 active alerts. Missouri is at 29. Kansas is at 22. Texas at 34. Nebraska at 19. Colorado at 27. Montana at 24. Add them up, and you get 404 active alerts across the lower 48. The National Weather Service has issued products for winter storms, for heat, for tornadoes, for fire, for flooding. Every season is represented. The atmosphere refused to pick a season. The operational products tell you what is happening. The peer-reviewed literature tells you why. The preconditions tell you what loaded the gun. The open question tells you what we do not know yet. The day will break. The pattern will change. The cold front that is currently moving through the Pacific Northwest will sweep across the Rockies on Wednesday and push into the plains by Wednesday night. The blizzard in Wyoming will end when the upslope flow shuts off. The heat in Boston will break when the ridge shifts eastward. The tornado threat in the plains will diminish when the cold front undercuts the warm sector. The fire weather in Texas will moderate when the winds subside. The flooding in Missouri will stop when the training thunderstorms move out. The pattern will break. But the next configuration is already in the data. The ensemble models are already showing another high-amplitude wave forming over the North Pacific in the 8 to 14-day timeframe. Whether that wave amplifies into a quasi-resonant configuration is not known yet. But the fact that the models keep showing high-amplitude waves, wave after wave, is the thing to pay attention to. The Kornhuber paper suggested that the models underestimate the frequency of these events. If that is true, then the next wave is more likely than the models say to amplify, and the wave after that is even more likely. The trend is the thing. The phrase that the Boston forecaster wrote this morning deserves to be repeated. Close to the maximum relative to climatology for the period of record. That phrase is going to show up in more forecast discussions before this year is out. It is going to show up in heat waves in Europe. It is going to show up in monsoon failures in India. It is going to show up in drought in the Amazon. It is going to show up in extreme precipitation events in East Asia. The phrase is the signal. When an operational forecaster writes that a variable is close to the maximum of the climatological record, they are telling you that the envelope is being pushed. The envelope is being pushed more often than the models predicted. That is the story that is not on social media. That is the story that is not in the conspiracy theories. That is the story that is happening right now, in real time, in the products that the National Weather Service issues every day. The blizzard and the heat wave and the tornadoes and the fire and the flood are not separate events. They are the same event. They are the same wave, the same Rossby wave, amplified, resonant, and more common than we thought. The practical implications are not abstract. The 2020 Kornhuber paper quantified the risk of concurrent crop failures in the world's breadbasket regions. When Rossby wave amplification occurs, the risk of simultaneous yield losses in North America, Europe, and Asia increases by a factor of 20. A factor of 20. That is the difference between a regional crop problem and a global food security problem. The paper estimated that a single wave event can reduce crop yields by 11% across the affected regions. 11% is not a small number. Global grain stocks are already tight. The drought in South America last year reduced soybean production. The heatwave in Europe last summer reduced wheat yields. The current wave event in North America is hitting the winter wheat crop in the southern plains during the filling stage. The winter wheat crop is already stressed by the drought. The heat that is coming with the ridge will accelerate the maturation and reduce the grain fill. The yield loss is already baked in. The same wave that is producing the blizzard and the tornadoes and the fire and the flood is also producing a crop loss that will show up in the USDA reports in August. That is the connection that the operational products do not make. The blizzard warning does not mention agriculture. The heat advisory does not mention supply chains. But the connection is there. The same physics, the same wave, the same consequences. The question that the research community is trying to answer is whether the frequency of these wave events is increasing because of climate change. The Petukov paper was theoretical. The Kornhuber papers have been observational. The answer that is emerging is that the frequency is increasing, but the mechanism is not straightforward. It is not that climate change is directly creating more waves. It is that climate change is altering the background state in which the waves exist. The Arctic is warming faster than the mid-latitudes. That reduces the temperature gradient that drives the westerlies. The reduced gradient slows the waves down. Slower waves are easier to resonate. The resonance condition is more likely to be met when the waves are moving slowly. That is the mechanism. The Arctic amplification, which is one of the most robust signals of climate change, is changing the propagation speed of Rossby waves. Slower waves, higher amplitude waves. More resonance events. The models are not capturing this well because the models have biases in their representation of Arctic amplification. The models warm the Arctic, but they do not warm it as fast as the observations show. The result is that the models have a weaker reduction in the temperature gradient and therefore a weaker reduction in wave propagation speed. That is the leading hypothesis for why the models underestimate the frequency of quasi-resonant amplification. The hypothesis is not proven, but it is the best explanation we have. The day is May 18th, 2026. The blizzard in Wyoming will continue through tomorrow morning. The heat in Boston will peak on Monday afternoon. The tornado outbreak in the plains will happen between 5 p.m. and midnight Eastern Time. The fire weather in Texas will be at its worst in the mid-afternoon. The flash flooding in Missouri will continue through the overnight hours. The same wave, the same calendar day, the same physics. The National Weather Service will issue its products. The Storm Prediction Center will update its outlooks. The Weather Prediction Center will issue its flood watches. The local officers will send out their warnings. The people in the path of the tornadoes will take shelter. The people in the path of the blizzard will stay off the roads. The people in Boston will turn on their air conditioners. The people in Texas will watch for smoke on the horizon. The people in Missouri will watch the water rise. And somewhere in the research labs and the university offices and the government agencies, the scientists will add another data point to the record, another event, another wave, another piece of evidence for the model observation gap. The honest framing is the one we have to leave you with. What we are watching is not a one-off, it is not a fluke, it is not a once-in-a-generation event that we can check off and forget about. What we are watching is what the atmosphere is becoming. The envelope is being pushed. The maximum relative to climatology is being approached more often. The wave is amplifying more frequently. The models are underestimating the risk. That is the pattern. That is the trend. That is the thing that is not on social media because it is too slow and too technical and too uncertain. But it is the thing that matters more than the blizzard or the heat wave or the tornadoes or the fire or the flood. The individual events are the symptoms. The underlying increase in wave amplitude and frequency is the disease. The open question is whether the frequency will continue to increase or whether it will plateau. The Kornhuber 2023 paper suggests that the frequency has already increased and that the models have not caught up. The next few years of observations will tell us whether that increase continues or whether the 2010s and 2020s were just a noisy period in a longer cycle. That is the honest answer. We do not know yet, but we are watching. The data are being collected. The models are being refined. The wave will amplify again. The question is when, not if. The I-80 corridor in Wyoming will be closed by midnight. The snowplows will go out when the winds drop below 35 miles per hour. The interstate will reopen sometime on Tuesday. The Boston heat will break on Wednesday when the cold front passes. The temperatures will drop from the mid-90s to the mid-70s in a matter of hours. The tornadoes that touch down in Kansas and Nebraska will be surveyed by the National Weather Service damage assessment teams. The EF ratings will be assigned. The fire in the Texas Panhandle will be contained. Eventually, the floodwaters in Missouri will recede. The alerts will expire. The 404 active alerts will drop to 300, then 200, then 100, then 0. The map will go quiet. But the next wave is already in the data. The ensemble models are showing another trough digging into the west in the 8 to 14-day time frame. The ridge that follows will be over the central United States. Whether that ridge amplifies into a quasi-resonant configuration is not known, but the background state is the same. The drought is still there. The soil moisture is still depleted. The aerosol unmasking is still happening. The ENSO transition is still underway. The megadrought baseline is still low. The loaded gun is still loaded. The next trigger is just a matter of time. The phrase from the Boston area forecast discussion is the one to remember, close to the maximum relative to climatology for the period of record. That phrase is the signature of a changing atmosphere. It is the signature of a wave that has amplified beyond the range that the climatology expects. It is the signature of a gap between what the models project and what the observations show. It is the signature of the open question that the research community is trying to answer. And it is the phrase that is going to show up more often. Listen for it. When you see that phrase in a forecast discussion, when you read that a temperature or a precipitation total or a wind speed is close to the maximum of the climatological record, you will know what it means. It means the wave is amplifying. It means the envelope is being pushed. It means the atmosphere is doing something that the models did not predict. It means the same physics that produced the blizzard and the heat wave and the tornadoes and the fire and the flood on May 18, 2026 is still at work. The wave will come again. The question is not whether. The question is when and where and how many of the 5 faces will show up at the same time. The answer to that question is in the data. The data are being collected right now. The next event is already taking shape. The atmosphere is not waiting for us to catch up. The science of quasi-resonant amplification is less than 15 years old. The Petukoff paper was published in 2013. The Kornhuber papers were published in 2020 and 2023. That is a young field. The observational record is short. The models are incomplete. The debate is active. That is not a weakness. That is how science works. The open question is real. The honest answer is that we do not know whether the frequency of these events will continue to increase or whether we are seeing a multi-decadal fluctuation. But the weight of the evidence is shifting. The 2023 paper showed that the models are underestimating the frequency. That is a signal. That is a reason to pay attention. That is a reason to watch the wave patterns and the forecast discussions and the peer-reviewed literature. The next 5 years will tell us a lot. The observations will accumulate, the models will improve, the open question will get closer to an answer. In the meantime, the blizzard warning in Wyoming is real. The heat advisory in Boston is real. The moderate risk of tornadoes in the plains is real. The extreme fire weather in Texas is real. The flash flood watch in Missouri is real. The wave is real. The physics is real. The consequences are real. That is the honest framing. That is the only framing that matters. The pattern breaks Wednesday. The cold front will sweep through the plains, the Midwest, and the East. The temperatures will drop, the winds will shift, the rain will end, the alerts will expire, the map will go quiet. But the quiet will not last. The next wave is already in the data. The ensemble mean shows another trough digging into the Pacific Northwest by the end of the month. The ridge that follows will be centered over the Mississippi Valley. The amplitude of that ridge is uncertain. The ensemble spread is large. That is the honest uncertainty. The models do not agree on whether the next wave will amplify, but the background state is the same. The drought is still there. The soil moisture is still depleted. The Arctic is still warm. The temperature gradient is still reduced. The conditions for quasi-resonant amplification are still present. Whether those conditions will produce an actual amplification event is a matter of the specific phase of the wave as it moves around the hemisphere. The timing matters. The alignment matters. The resonance condition is specific. Not every wave amplifies, but more of them are amplifying than the models predicted. That is the signal. That is the thing to remember. The blizzard in Wyoming will drop 12 to 18 inches of snow in the mountains. The I-80 corridor will see 6 to 10 inches. The winds will create drifts of 3 to 5 feet. The National Guard has been placed on standby. The Wyoming Department of Transportation has staged snowplows at Rawlins, Laramie, and Cheyenne. The closures will happen. The people who ignore the warnings will get stuck. The rescue operations will happen. That is the script for every blizzard. The difference is the date. May 18, the same date that the Boston Forecast Office wrote about, 850 millibar temperatures 2 to 3 standard deviations above the climatology. The same date that the Storm Prediction Center issued a moderate risk for tornadoes. The same date that the fire weather outlook went to extreme. The same date that the flash flood watch went up for Missouri, May 18. A date that will be in the record books. A date that the reanalysis datasets will flag. A date that the attribution studies will analyze. A date that the research papers will cite. May 18th, 2026, the day the wave amplified. The conclusion that the research community is moving toward is not that every extreme weather event is caused by quasi-resonant amplification. Most extreme events are not. The wave has to be in the right configuration. The wave number has to be 5, 6, or 7. The wave has to slow down. The resonance has to occur. That is a specific set of conditions. That set of conditions is happening more often. But it is still rare. The majority of days do not have quasi-resonant amplification. The majority of extreme events are not linked to quasi-resonant amplification, but the events that are linked, the events like today, are the ones that produce the most severe and the most widespread impacts. The blizzard and the heat wave and the tornadoes and the fire and the flood on the same day. That is not a typical extreme event. That is a quasi-resonant amplification event. That is the class of event that the Kornhuber papers have documented. That is the class of event that the models underestimate. That is the class of event that is becoming more common. Not every extreme event, but the most extreme extremes. The ones that break the climatological records. The ones that push the envelope. Those are the ones that are increasing in frequency. Those are the ones to watch. The National Weather Service will continue to issue its products. The warnings will go out, the alerts will flash, the map will fill up and empty out, and fill up again. The pattern will break and rebuild. The wave will propagate and amplify and decay. The seasons will pass. The climate will continue to change. The open question will remain open for a while longer. The evidence will accumulate. The models will improve. The science will advance. And on some future day, maybe next year, maybe 5 years from now, maybe 10 years from now, the same phrase will appear in an area forecast discussion, close to the maximum relative to climatology for the period of record. And when you see that phrase, you will remember May 18th, 2026. You will remember the blizzard and the heat wave and the tornadoes and the fire and the flood. You will remember the wave. You will remember the open question. And you will know that the atmosphere is still pushing the envelope. The envelope is not static. The maximum relative to climatology is not fixed. The maximum keeps moving. The period of record keeps getting longer. The maximum keeps getting higher. That is the signal. That is the trend. That is the thing that is not on social media because it is too slow and too technical and too uncertain. But it is the thing that matters. The wave is amplifying. The envelope is being pushed. The maximum is moving. And the next wave is already in the data.